This is a workshop to essentially describe from concept to in service. And there are numerous questions and answers that owners and engineering companies work together with to help make these decisions as to the process of all of the options to consider and how to answer those questions, how to work through the options. And so what our intent today is to discuss some of our experience with these applications, working with varied clients throughout the country and actually throughout the world for overseas projects. So we have a team today with many, many years of experience assisting clients with development, developing these solutions and answers to these questions. And today we will cover a few of these. And after the presentation, we will have questions afterwards. I'm Paul Hinkle. I'm the Director of Gas and Sulfur at Matrix Service, Matrix PDM. Jim Hauser is with us. He is the Director of Engineering for Matrix PDM. And also on board is Gary Phillips and Gloria Polly. Both are Directors of Business Development. So these are the folks that'll be contacting you at times to get the ball rolling, starting to work on projects with you as you start to have interest in projects that are coming up, or just want to discuss with somebody for a project or opportunities that you have. So don't be surprised if you hear from these folks in the future. So to start with, I'm going to give a little background of Matrix and some of the history, where we are, what we do, what we have done in the past, give you a much more comfortable understanding of some of our experience.
We'll have to take a look at it. 1478 Northwest, about 9 minutes out from there. Why is close right now, Papa?
Okay, just a little note on the Matrix family of companies, Matrix PDM Engineering, which is what this team today is comprised of. And we also have Matrix North America Construction, which is one of our construction companies, mainly works up in the Northeastern region. They're a union contractor. Matrix Service, which most of you are familiar with, is our tank division, building not only tanks, but tank farms, piping, and industrial applications. And Matrix Applied Technologies is more of a products division, building geodesic domes and all, with offices in South Korea and Australia. Matrix PDM is, we have 4 locations that we base out of, that we perform the engineering. Tulsa, Oklahoma, New Orleans area, Columbus, Ohio, and Pittsburgh. Just a short view of a list of clients that we have worked for through the years. Matrix Company was founded in the 1980s, and since then has enjoyed a lot of success with a varied group of clientele, very diverse, and with a lot of repeat business back with them. So starting off on the gas workshop, essentially the client starts with a need from their commercial group to address processing gas or moving gas. And so they, essentially get the ball rolling. And so there are several things that they have to consider as they're getting started is picking the right location. And part of that, once they're they have a general area that they want to process this gas in, a couple of the early items that they have to consider is getting the permits. Some areas the permits are fairly easy to get, and some areas they're very difficult. And so some of the considerations that you'll want to keep in mind as you start through the original process of where you would like to locate your plant or your station is, where will you get the power from? How far away is it? And can it be completed in a timely manner? So that's one of the issues. I know that we've had several projects that were delayed in service just due to the fact the power company was not able to get power there in time. So after that, and then you'll look at customer connections for pipelines for gas coming in, your takeaway room. Also, is there, when you develop a site, do you want to plan ahead for possible expansion to where, right now you have an agreement for a certain volume of gas, but you think that right around the corner you may have others. So as you go to select these sites, you want to consider all of that if you're going to anticipate expansion fairly quickly or even down the road. So once you pick the areas that you wish to build a plan in or your stations, is you need to consider the challenges that go with the property that you pick. In some areas, it's fairly simple. Out in the Permian, most of it is pretty flat profiles with a caliche base, whereas up in the Northeast, in the Pennsylvania, West Virginia areas, typically you're having to cut the top off of a mountain. As the pictures indicate on the screen, it's very extensive work in the Northeast. It will have a great schedule impact and a even more great cost impact, and especially as you consider expansion. Whereas in the Permian, it's fairly typical to, just move right adjacent to from one plant to the next. Or in the Northeast and other areas of rougher terrain, you'll have to consider, which direction and how you want to expand. Do you want to tackle that at the front end, or do you anticipate more civil work and challenges as your growth continues? One of the other considerations, or a few of them, are your pipeline routes and access to these pipelines and stations and plants, your pipeline takeaway space for gas and condensate, and if you'll be trucking product, condensate into the plants for processing, or even trucking product out. One of the things that Matrix has really done a great job of, and we're really proud of here, is the promotion of standardization and duplication. So in the picture here essentially is a large piece of property that from the very onset, the intention was to build several plants side by side. taking advantage of the duplication opportunities to make these plants almost identical, but also allowing for variations and changes of different types of technology packages that may be coming in. And also considering the maintenance aspect to be able to leave room for that access to get into the equipment. But the intent was to almost duplicate or cookie cut so that we have real schedule and cost savings on the not only the engineering but the construction access to be able to much more quickly bring the bring the plants on.
Paul, I just wanted to make sure we're going through a bunch of different slides here. I didn't know. It looked like we skipped over a couple slides from that picture. I might be wrong, but I had some.
We did. I'm back to them now.
Okay, great. Thanks.
Okay. So the next consideration is choosing the right partners. So who are you going to team with for your engineering, procurement, and construction, and the balance of plant integration? So that is another thing that Matrix takes a lot of pride in on how we've successfully accomplished that through the years on many projects. And I'll go through a few examples. So selecting the right team for your project starts with typically with the engineering. So you want to have an engineering group that has the same mindset and experience. They also are capable of monitoring the whole project and managing the whole project from an EPC side, evaluating your earned values and execution with the customer in mind. From a construction aspect, you want to put your main focus on safety first, schedule. Naturally, cost is always a big item with that. And will they give you the ability to make adjustments to your scope if you have a need arise during the construction of the project? And lastly, the technology and equipment sourcing, which I said lastly, which is probably one of the first things that you'll be thinking of as you go to plan. But again, looking at standardizing, or will you need a custom plant? So those are the things that you'll be considering, as you start through this process. Who will your partners be? How will you be able to team with them? Will you be able to work with them and their personalities well? But you want to size the equipment to meet your requirements for today, but also for tomorrow. You want to also evaluate your expected gas composition, your air permit requirements. Will you need a NACE design for the plant? Will you be incorporating stabilizers, gas or liquid treating, slug catcher size, compression and horsepower, turbo expanders? Will you possibly need a sulfur recovery unit? So those are all things that you want to try to think of up front, so that at the beginning, while you start the project, working with your technology suppliers, you have these discussions. You also are working as a team with your engineering firm to consider all of these within the design criteria. So your engineering partner should have a clear understanding of your current and future plans for each project. You want to reduce or eliminate your expansion limitations if possible. You want to consider an engineering partner that has vast project experience with similar equipment. Modularization. We take a lot of pride that, we feel like we were at the onset of modularization to where you can do a vast amount of your construction, your fabrication, and all offsite, and design repeatable duplication for cost and schedule savings. Earned value, schedule monitoring, and report integration for all partners into one schedule. This makes it much simpler for you to see how your project is progressing through every phase of the construction process if you're able to look at one schedule and know what your major milestones are that you need to accomplish throughout the project to know that every discipline is staying on track. Your balance of plant integration of partner engineering and equipment into overall plant design is critical. To be able to marry all of this equipment together, to know that the design partner is going to not build in any limitations. They're going to allow all of the technology to perform as designed. You want to maximize your modularization for offsite fabrication and assembly for cost and schedule attainment. Controls design and implementation including loop and commissioning support. That is a lot of times overlooked and something that you need to give great consideration to, because that is actually the operations of your plant, is how well your control design and scheme is put out and tested and checked throughout the construction phase. FAT performance. You want someone that will be able to attend FAT performance testing, to be able to provide input to vendors and confirm that everything is going to perform as designed. And successful teaming experience with construction and fabrication partners as required. So Matrix PDM has vast experience successfully providing EP service for many clients in varied locations, domestically and overseas, teaming with multiple technology partners. We've completed 13 processing plants with over 3 BCF, as well as many compressor stations. CII did a study and essentially took 7 projects with multiple duplication and did an evaluation on it just to see what the cost and schedule impact is on duplication and standardization. So this is a slide from one of their presentations, but essentially have this in here to point out that, even though we work with CII, we expect that a lot of you do too, and may have seen some of their presentations. But essentially throughout the life cycle of several projects, they were able to prove with actual projects the accelerated project schedule, accelerated engineering, reduced engineering man hours and cost, procurement repeatability, improved construction and material management. And the idea is that you design it once and you reuse it multiple times. Even if you do make modifications and changes, it's still attainable with standardization. Here's an example of the same plant that you saw in the picture, where from a top view you can see that by design each of the plant very closely resembles each other, although none of the 3 are exactly the same. But with these 3 projects, project 1 was on time, on budget, on schedule. But project 2, we were able to improve that dramatically from the beginning, even though some of the equipment changes were there and you had to re-engineer certain areas. But the basic layout was the same, the modularization, you were able to get repeatability, and all of the engineering phases of it went much quicker and smoother in phase 2. In phase 3, almost every bit of engineering was able to be reused. You want to have an engineering company that's able to check it, verify it, and just make sure you're on the same page. But really sped up the project from a engineering aspect of it and also a construction aspect.
Hey, Paul, well, one thing you'll probably mention this later, but there's a real benefit to the future operation and maintenance of those plants as well. When you standardize them, you have more common, maintenance practices and things that can be achieved as well.
That's correct, Gary, and that's a good point. one of the key items that go with that is, your spare parts. If you have common technology partners for many plants, just as in this case with 3 plants, you still only need to have, maybe 1 set of spare parts and all, and the maintenance consistency is there and much more attainable. So what I'm showing here is, ideally you want an engineering partner that will provide the 3D modeling with clash detection, and you do pre-construction reviews with the client, and typically that's done at a 30%, 60%, and a 90%. And you also do a HAZOP review, fairly early in the project of your P&IDs. So that's another aspect as you select your engineering and construction partners, is somebody that has the ability to offer the latest technology in their designing and engineering practices to make sure that all of your bases are covered in the design of your project. Along with that, you want to make sure that your partners are designing with safety in mind and repeatability, not only for the construction, but the operations and the maintenance. And the intent of this picture is just to show this is a site that's under construction, but right adjacent to it, you can see the pad that's designed for Plant 2. And, so from the beginning stages, even though it may be years away before you intend to expand, that when you select your site, you can have cost savings by adding T's and valves and things in Plant 1 in preparation for possibly going to Plant 2, and minimizing downtime of having to shut a plant down to make those tie-ins and all, so that you're considering that up front. So I mentioned modularization, and we talk about it quite a bit. The idea is to design for the future. This is a plant in Pennsylvania, but with modularization, you get much improved safety, because most of your fabrication is in a controlled environment in a fab shop with a lot of repeatability. You get improved productivity that way, because you have the same people building them over and over and over again, similar to what Henry Ford come up with for the early model Ford cars. You get improved product quality because of that repeatability. Improved scalability. If you need to make a modification to expand some pipe racks or shrink them down a little bit, much easier to do in a fab shop rather than stick building it in the field. You get standardization, that during construction, there's a lot of repeatability to it. The guys get used to understanding how they're built, how they bolt up, how they're installed, and the processes that go with that. It also reduces fabrication and construction costs. For one, you're out of the weather. You have a controlled environment. You have an improved NDT, NDE program, just because of the general location of building all of the equipment on one location at a fab shop, with the ability to control all aspects. It improves the schedule because you can plan for it, ordering material for building, doing the construction and all. Your duplication helps with all aspects, and you're reducing the field manpower requirements, which has a lot of impact on your job cost. You're not paying per diems or anything. You're not out in the weather. You don't have the travel concerns or anything like that, especially right now with the COVID. So modularization is a big key. So Timely Engineer supports accelerated construction, and the example I'm showing here is the ability to ultimately engineer nearly all of the foundations well ahead of the time the equipment is going to be arriving, so that the construction group almost has a blank sheet of paper to go out with their survey crew, lay all of this out, perform the construction on the foundations well ahead of the arrival of any of the equipment or pipe racks or anything. So from a safety and a time aspect, it just really speaks volumes to the ability to maintain your schedule. Some other construction considerations when you're considering your construction partner is, is it in an area where you'll need union or non-union options to consider? You will look for their safety performance, and that's so critical in all projects, is the safety aspect of it. You want somebody with proven construction management, somebody that's done this over and over, somebody that's willing to work with you, that wants to develop that relationship and continually is aspiring to meet your needs. Schedule adherence and performance assurance require clear understanding of client intentions. And client intentions sometimes change, and that just needs to be communicated. And the point here is, that you have a clear path of communication with your construction partner. Assembly and installation of modules and equipment. Someone that understands the benefits of modularization and standardization, and that they will price the project to you accordingly with those benefits in mind. The quality NDE, NDT that go along with the construction aspect. And I mentioned earlier the control side of it, the I&E, is a very, very important aspect of the construction side of it. And the last bullet is the manpower resources. You want to make sure that you don't get halfway through the project and somebody down the road offers $1 or $2 an hour and they lose all their people, and you're stuck without a contractor. So you definitely want to consider somebody that is definitely able to manage the schedule, manage the cost, and manage the construction per your schedule and per your needs. Project execution is to me, the lifeblood for the engineering and construction. So managing the project, earn value, which is cost control, tracking, integrating all parties. So you're monitoring not only the civil group all the way through the I&E, the loop checking, but every phase of every contractor, every team, every partner, even your vendors, your technology partners. So your engineering firm should be able to communicate clearly with all of the team participants, whether it is vendors that the engineering company has hired during the procurement process, or whether they're the client vendors providing compressors or technology packages, a cryo or refrigerant plant. So you need somebody with the ability to monitor all aspects, keep everybody on track, and working in the right path as a team. Your MOC integration and monitoring, somebody to work with you directly to be able to make those accomplish any of the changes that are needed. Integrated and updated schedule, so everybody is working off the same sheet of paper, same calendar. Reporting and communication of all parties. Duplication allows for repeatable results with improved cost and schedule. Consistent EPC teams can improve project execution success. So at the start of the job, you're answering a lot of questions, making a lot of plans, and ultimately every step is to get you to mechanical complete and to get you in service. So here you want to absolutely consider who you want to be teamed with for your SAT support and compliance, construction pre-commissioning support, and your commissioning support. Ideally that, the owner is very involved with that. but again, you want somebody that is on your team that is working towards the same goal that you are. So you've got the plant built, it's in service, and commercial comes and we need to expand. So, you know, what are the possibilities? What are the considerations? You know, do you add processing equipment? Did you discover that now you need a sulfur recovery unit? Or do you need to move more gas through your plant? Do you expand it? Do you build another plant? Do you duplicate it? So there are a lot of considerations once you get your plant in operation. So, you know, do you go to plants 1, 2, 3, and 4? So as I said earlier, you want to plan for that early. You want to design for expansion early to allow that to minimize disruptions to what you've already built. And you want to construct with expansion planned and in mind. So the end of the presentation, we have a panel here that is looking forward to taking some of your questions. I'll leave the slide up here so that you have their names and what their roles are. But we will now take questions.
Yeah, just to mention that if you're muted, you might want to unmute yourself. I think everybody might have been muted for the presentation portion, so please do unmute if you would like to ask a question, make a comment. I'll just go ahead and throw it out there. Is anyone on the phone have any challenges that Paul may not have touched upon that you faced, you know, things we may not have had experience with and discussed here today? Have you had challenges with regard to design and construction of your plants or facilities?
So this is Jim Rasky, William.
Hey, Jim.
I was curious, you mentioned, you know, engineer it once and reuse it. Do you see significant cost savings on the engineering from, you know, the plants as you expand your facility? You know, you do plants 2, 3, and 4, or is that, just curious to see, you know, the benefits there? I assume there's a lot of schedule in, you know, schedule efficiency, but is there any cost efficiencies?
Well, I'm not sure who you directed that to, Jim, but that's a great question, and I appreciate you asking that. The examples presentation was a perfect example of the cost savings and the schedule impact on that. And so essentially, we built 3 processing plants on one plot of ground or one location, but it was designed that way from the beginning. But as you may have noticed in the 3D model or even in the area plan, that they are a lot of similarity. So from a cost aspect, the engineering cost, I wouldn't say it was cut in half, but it was nearly half. The construction cost was greatly reduced on it. And not only that, the schedule was improved by quite a few months, you know, I'd say 4 months at least. I don't know if that answers your question there, Jim.
Yeah, no, absolutely. Thank you. Yeah, that was kind of what I was trying to gather was what kind of savings you can expect if you go that modular kind of route and design it once, build it multiple times. So thank you.
We have a question that's come up on the chat here, actually, so I'll direct it to you, Paul. in case the site access has restrictions, it says to allow headroom for only 5.5 meters. How good could modularization help in that instance?
Well, I'm going to put Jim Hauser on the hot seat there for that one.
Well, thank you, Paul, and good morning to everybody that's here. Glad you're here. I'm not quite sure that I understand the headroom requirement. Is that a function of the clearances to get equipment to the site?
I've just asked the participant to unmute, so perhaps they
Well,
can
I
ask the
thought maybe
question.
the person might respond back.
Yeah.
So,
Hello.
hello.
Good evening, Jim Hauser. Our particular site is not an open area site. The presentation which you had showed really lucky sites because access can be had from any other site. Here in India, what has happened is that most of the refineries or hydrocarbon petrochemical facilities, be it, they all are, most of them have access limitations. Like even from the highways, you can't bring in equipments which are more than 5.5. 5.5 is the headroom available. And also inside the refineries and petrochemical units also, we have got our old pipe racks, which allow only up to 5.5 meters. So which means for a trailer, even if you bring it in a trailer, the equipment can be brought only up to 5 meters. So we do most of the vessel fabrication, large dia vessel fabrication at site, or else we bring it as petals and do it inside. Now, I am more interested in the modularization portion of it. The modularization portion, how does, in the open sites which you have displayed on this, which displayed on your presentation, they all look very attractive, and modularization really gives you an advantage there. But here in our site, where probably the module can be max is 5 meters, might be the width wise it can be slightly wider, 6 meters or so, but not beyond that. So will modularization have a real benefit? Over.
Well, we still believe that it does, and from our internal standpoints, whenever we secure contracts and we look at the execution in the planning phase of that, the overall logistics of shipping equipment in, regardless, taking into consideration the physical size of the equipment, the restrictions that we have from the point of manufacture to the destination, as well as the internal restrictions inside the fence, whether it be power line crossings, pipe rack crossings over roads. All of these things are taken into consideration, both in terms of the design and the size of the modularization that we look at, the size of the equipment, the means of how we're going to transport, depending on the situations. We have actually in the past modified roads were necessary in order to obtain an additional clearance to get it, because the cost of modifying to lower the road a couple of 3 feet had great benefits compared to the other clearance restrictions that we have. So there is no definite answer, but every project has its own unique logistics that we always take into consideration when we come up with the designs that we do. A classic example of several years ago that on an international project, we had very tight restrictions in terms of the modules that we had, that they could be no more than, I think it was 3.5 meters wide, maybe 4 meters tall, and a length restriction. I just don't remember what it was. But we took that into consideration right up front in our design, and the size limitations because of those shipping restrictions just got us back into an area where, instead of, in this case, maybe we could have done it with 70 modules, this facility had 86 or 90 modules total included in it. So all of those things are taken into consideration as we do the evaluation. I hope that answers your question.
Yeah, thank you. Thanks for that explanation. So I was just wondering whether 5.5 meter is itself is a constraining dimension. Now that I have heard 3 and 4.5 meters, feel a bit elated. So now in one of your slides, it was mentioned as union or non-union option. What was that? Can you go back 1 or 2 slides? There was something called union or non-union option. What is the terminology used? Yeah. Here, what was that union or non-union? Is it flanged mechanism you're mentioning, or?
Well, here in the U.S., certain areas have very strong union
Oh,
presence.
fine. That. Okay, right. You mean the labor, industrial labor issues? Am I right?
Correct. Yes.
Fine. Thank you. And by the way, is Matrix PDM anywhere done jobs in India or in the Asian subcontinent just for an academic interest?
Again, I'll let Jim. I don't know of any projects that we've completed in India. We have done some in Asia, and we continue to work some in the Middle East. But I'd let Jim be more specific. He, as you can tell by the beard, he's been here longer than I have.
Thanks, Paul. No, I'm not aware of any projects that we've actually fabricated, shipped, or installed in India, at least not in my career. So,
thank you.
However, we do have partners in India. If you have a project that needs to be looked at, we'd be more than happy to take a look and put you in touch with our partner.
Sure, thank you.
That's a good call, Gloria. And just so you know, we do have partners strategically all around the world that we work with, and we try to team. As I started the conversation, you need to pick your team very carefully, and typically, if you have something, feel free to reach out to either myself, Gary, or Gloria, and we can team you up with our partners that are more strategically located to work with you.
I have another question submitted to me on the chat. The question is, what is the incremental cost of the second tranche of duplication with a very high degree of modularization versus the first phase?
I wanted to go back to the CII slide that completed the study of 7 consistent projects that were duplicated. It's a much more in-depth study. Personally, I can comment a little bit better on my personal experience and our experience here at Matrix, that the overall cost, and I know you'd like for me to put a number of is it 80%, 70%, 60%. I don't have the complete evaluation of it, but as an estimate, from the first plant to the second plant, we probably had about a 10% savings in engineering and construction, and then by the third plant, it was probably at least another 10%, and maybe even more on the engineering and construction. And the design is still there, and with this particular client, nearly every new location that we discuss That is the comment. Let's just take that same plant and duplicate it over here, or take that same plant, we'll duplicate it over here. So, you know, it's not only the repeatability, but also the standardization of the equipment, the technology, and all that goes with it that supports that.
Paul, would it be safe to say that a lot of customers have learned over the last several years in the shale boom, where they've learned the benefits of standardization, modulation, and they've gotten more mature with regard to standardizing equipment and things like that as well. So they've gotten better at it as well, which helps the engineering and construction partners.
Absolutely. Any portion of the project that you can repeat with like equipment, you know, but you know, just be warned that even though, you know, we may design all of the foundation for the whole plant, for all of the technology package in one area, and you wish to build that 40 miles down the road, does not necessarily mean that those same foundation designs will be applicable because of the geotech report and the ground concerns, or is it in an earthquake zone or anything. So, you know, I don't want to mislead you to think that every portion of a plant can be picked up and carried to another state or something, and every piece of it be duplicated. It may be, but you have to do some engineering consideration on that, you know, before you make, you know, before I can make a broad statement like that.
Sure, I have a follow-up question to that from the same person. How do you incorporate lessons learned from the first phase of the execution into the second duplicate phase?
Well, y'all may get tired of hearing me talk, but we do a lessons learned, and we don't necessarily wait till the end of the project. Every project has several phases that it goes through, you know, through your civil, then your foundations, then your structural, your piping. So as we complete each of these discipline phases, we purposefully do a lessons learned and really do an in-depth study and report on what we've learned through each project, to make sure, for one, that we don't duplicate our errors if there are any, or if there are any challenges that we've created. We're always looking for ways to improve. So we are continually doing lessons learned studies and generating reports and working within our engineering teams, which is another advantage that I didn't really get into too much, is keeping your teams together. From an engineering aspect, you know, we try to keep consistently high performing teams all together to continue to work as a team, whether it's electrical engineers, pipe designers, process engineers, so that we retain that commonality and that knowledge as a group to work consistently from our end on the project. And then we also encourage that on the construction side to try to keep the same mechanical contractor, try to keep the same teams together, the same electrical teams, the same controls teams. And, you know, at one of the locations that we discussed, we were very fortunate that we were able to keep the same engineering, the same construction, the same electrical and controls team for 3 projects in a row, and you really gain a lot of consistency, and that really adds to the cost savings and the schedule attainment also. Did that answer your question?
I think so. We have another question actually. What is the role of major package vendors in gas processing plants, and how does Matrix interface with them and manage them?
Well, I'll take part of it and then invite Jim back in here in a minute. The role they play, you know, as I mentioned at the beginning, the client, the owner, will have a you know, a level of gas, you know, that he's expecting to come in. And so he wants the overall design to be able to incorporate his expected, you know, gas resource to, you know, he may know whether it's going to stay the same or it may vary as wells change or as different wells are brought on. So his gas consistency, you know, may be expected to vary. But at the very beginning, you know, he will provide that to the engineering company, and also he will provide that to his technology providers so that they're able to do their, you know, provide their design to incorporate any of the aspects that are expected in the client's life cycle of the gas plant. And so they will take and design, you know, whether it's a stabilizer or an amine system or even a flare, and also they will do their design and, you know, have a performance guarantee that stands behind that based on the information the client has given them. And then from a balance of plant packaging engineering company, we will consider each one of their designs as we design the balance of plant to make sure that we're supporting their design and their performance that they're trying to achieve or that they're guaranteeing to achieve, to make sure that we're making the whole plant work as one instead of as 5 different pieces or 5 different technologies. That's what we do, is we integrate it all into one common plant that works seamlessly. And I'll let Jim elaborate more on that.
Well, thank you, Paul. You know, I think the real thing to respond to the question is the fact that with the technology providers that exist and the relationships that we as an organization have developed with these technology providers through the years, allows us to do it almost in a partnership basis, to where whether or not the owner of the facility has purchased the technology or the contracts are written such that we purchase the technology, the overall management of these companies and the integration of their data and schedules and designs into the facility really occurs on an almost seamless basis. And again, it's through the relationships that have been developed through the number of years of working with these organizations and the number of facilities that have been done. So while the owner may turn over the management, and when I say the management, I'm really talking about the schedule attainment, the deliverables as the drawings and the final deliverables of the fabricated items and so forth to us. The owners have gone ahead and purchased that, and we operate seamlessly as a team. So I hope that answered that question.
I have one more question from Parma. The question is the typical norm nowadays to use industry standards of project execution versus client-specific engineering and project execution standards?
Paul, you want to tackle the execution side?
All right, I'll tackle that. You know, there are various standards out there, but yes, I think we, you know, want to focus on consistency again, you know, with all of our standards. So, you know, we don't create new standards here to accommodate that, although, the reporting, the earned value, and all are standards that are, widely recognized worldwide. So we build on that. Our project controls team, have designed, but we will do that in a, what I would call a weekly or biweekly report where we monitor all aspects of the project, even down to weld inches and loops and, how much structural, how much concrete by weight, rebar. So really there's no aspect of the project that we don't monitor on earned value tracking, which also includes all of our drawings. At the beginning of the job, we sit down and by discipline put out a list of engineering deliverables and drawing deliverables that will be included within the project. And naturally, there's always some variation of that. But from day one all the way through the very end, we do earned value tracking and reporting on a consistent basis to make every area of the project transparent to the client. And what we've learned is that's just invaluable to them to be able to understand where each piece of equipment is in its life cycle of being fabricated or shipped to the site, even down to valves and instruments. And also, no, we do a very good job of tracking everything, whether it's through procurement, design, engineering, and all. And we do that in a composite report on a consistent basis.
Well, I'll just add to that, obviously your EPC or engineering standalone contracts are going to require certain things from the customer with regard to how the project's managed, and we comply with and adhere to the contract requirements. I would say that we typically go, our standard internal processes are usually sufficient to meet the contract requirements, and then we just adjust, based on that particular customer's requirements if we need to.
From an engineering standard point of view, there is no set answer. It's a function of the client, the size of the client themselves. We deal with a great number of clientele that have no standards. So they will take, in some cases, they might just adopt all the PIP standards and want their facilities designed that way. Some of them will even take back and say, depending on the technology provider, technology providers have their own internal standards and they will just follow those. Again, as Paul mentioned earlier, some of the technology providers out there have adopted the old Henry Ford attitude. You can have any color that you want as long as it's black. And these technology providers, they provide a standard unit, whether it's glycol dehydration, amine regeneration, cryogenic gas separation, emulsive dehydration. You want it fast, you want it economical, you take their standards. We also deal with other clients that have written in their specific things of what they may want throughout their facility. Obviously, all of the standards that they generate still have to meet any national or international code requirements, but they may make them more stringent in terms of, one of the classic ones we see is, regardless of piping pressure class, you won't use anything less than class 300-pound flanges and valves. Certain pipe wall schedules, they wouldn't use less than Schedule 80. So, that's just a function of the clientele that's out there and the business that they're in. And basically, it really boils down to the size of the organization. So.
I think we've reached 12 o'clock, and I think they've cut off the chat questions, I think. So we're done with those, I believe. Correct, Bridget?
Correct. There's no more questions coming in.
Just want to be cognizant of everybody's time and whatnot. I'd just like to say, from my perspective, Gloria and I, recently joined Matrix. We're going to be working together on from the business development and client interface engagement. So if you have any needs, it doesn't have to be an engineering package or EPC. We can do parts and parcel, of whether it's just electrical or automation or civil, or we can do the whole ball of wax. So it doesn't have to be the whole engineering package. We can parcel out certain aspects of it, and we'd be happy to do that. We'd also be interested in doing, helping you with your concepts and studies and, estimating projects, doing feed to help you kind of develop your projects that, you're considering. So please just let us know if there's any way we can help you with your projects in the future. And I know there's some large EPC companies on the phone as well, and we certainly would love to support you locally if you have any needs or need some support. So thanks for joining. I really appreciate it. I've learned a lot today. Thanks, Paul, for leading the effort.
Thank you.
No, absolutely. I appreciate everybody that joined, and hopefully that you were able to get a copy of our email addresses and phone numbers, and I welcome questions and comments afterwards at any time. So please feel free to reach out to any of us. Thank you very much.